Hello everyone, welcome to this class. So in this MOOC course, we are going to talk about sets and algebra. So in the first phase of it, we will be discussing about sets. So in this particular lecture, we will be talking about introduction to sets, in particular part 1, where we will be discussing about sets and their representations. So quickly about myself, my name is Devanga Raj Neo. I am an assistant professor in Mehta Family School of Data Science and AI in IIT Guwahati. I am also an associate faculty in the Department of Design, IIT Guwahati. I did my PhD from University of British Columbia, Vancouver, Canada, and I got my BTech in Electronics and Communication Engineering from Indian Institute of Technology, Guwahati. So let's look at the outline of this lecture. So first, I will tell you the motivation behind using sets. Then we'll define what is a set. Then we will look at the representation of a set. And finally, I will tell you some resources for further discussion and further learning. So first, let's think about a collection of objects. So when I say this phrase, collection of objects, what does come to your mind? So we can think of collection of cards, collection of vegetables, collection of even numbers between 1 and 9, and so on. So now we can define a set. A set is a well-defined collection of objects. So we often use the words like objects, elements, and members to represent the members of a set, and these all are synonymous terms. So sets are usually denoted by capital letters like capital A, capital B, capital X, capital Y, etc. And the elements of a set, which are the objects in this collection, these are represented by small letters like small a, small x, etc. So now we will look at this phrase, small a belongs to capital A. Okay, so if small a is an element of a set capital A, we say that small a belongs to capital A. The Greek symbol epsilon is used to denote this phrase belongs to, right? So we write in this particular way, small a belongs to capital A. Now if small b is not an element of a set capital A, we write small b doesn't belong to the set capital A. So that's what we read as, and the notation as you can see here. For example, let's consider a set of all natural numbers. This is usually denoted by this symbol n. So if we consider an integer, a natural number 5, then we can write 5 belongs to the set of all natural numbers. Now, how to represent a set? So there are usually two methods to represent a set. The first one is known as roster or tabular form, and the second one is known as the set builder form. So what is a roster or tabular form? So in this particular form, all the elements of a set are listed, and the elements are separated by commas and are enclosed within braces. So the set of all natural numbers which divide 42, let's consider this case. In this particular case, we can write this set in roster or tabular form in this particular way, where we are listing all the elements 1, 2, 3, 6, 7, 14, 21, 42 within the braces and separated by commas. And as you can see, all these numbers divide 42. Now I have a question for you. The question is the order in which the elements are listed in a set important? The answer is no. So for example, we are showing two sets here. First one is 1, 2, 3, 6, 7, 14, 21 and 42. This set is actually same with another set 1, 3, 7, 21, 2, 6, 14 and 42. And as you can clearly see, the elements of both the sets are same, just the order is different. But actually both are the same set. Okay. So this order is not important. The second question is, can there be repeated elements in a set? Now the answer is no. The set of letters forming the word school, for example, which has SCHOOL, can be represented by the set SCHOL or HOLCS, right? So both the sets, as you can see, has the same set of elements, and O is not repeated. And since we have already seen that the order is not important, so both are the same set, right? We don't have to mention the repeated elements. Now let's talk about the second way of representing a set, which is known as set builder form. So in this particular form, all the elements of a set possesses a single common property that is not possessed by any other elements outside the set. So every element of the set has something common. So for example, in the set A, E, I, O, U, all small letters in this case, all the elements possess a common property, namely each of them is a vowel in the English alphabet, and no other letters in the English alphabet possesses this particular property. So the example, so if we denote this particular set by capital V, we can write it as capital V is equal to small x, such that small x is a vowel in English alphabet, and as you can see, they are enclosed within braces. Now let's look at an example. So in this example, we are asked to write a set capital A, where capital A is equal to small x, such that small x is a positive integer and x squared is less than 40, and we have to write it in a roster form, and the answer would be something like this. So as you can see, in this particular set, we have 1, 2, 3, 4, 5, 6 as the element of the set, and all of them satisfy the property that they are positive integer and squared of each of the elements is less than 40. Now let's look at a second example. In this case, we are asked to write a set capital A is equal to 1, 4, 9, 16, 25 and so on, it goes on, in a set builder form. So we can write it as capital A is equal to small x, such that small x is the square of a natural number, or capital A is equal to small x, such that small x is equal to n square, where n belongs to the set of all natural numbers. And you can clearly see that this is true, because if you look at the roster form, you can see there are all the natural numbers which are squared of the, which actually satisfy these two properties, this property, right? So x is equal to n squared, or x is a square of a natural number. So this way we can write in the set builder form. So for further resources in this topic, you can look at the NCERT class 11 mathematics textbook. In particular, you can look at chapter number 1.1 and 1.2. Thank you, and I'll see you in the next class.